Okay, this is Jump Math 6, Book 2, and we're on page 54, rotations. So this is typically the most difficult of the transformations. So transformations again are translations, which are slides, reflections, which are flips, and rotations, which are sometimes called turns. So rotations or turns. Uh, so let's get right into it. And this one tends to be the most difficult to visualize. So please try your best and see how it goes. It says from the dark arrow, draw an arc showing the direction of the given 90-degree turn. Draw the arrow after turning. So here for B, I'll do C. It says counterclockwise. So we go like this, and then we draw in the arrow. So I'm going to see if I can draw it in black like that. But yeah, that's not a bad arrow. Okay, and let's jump over to the next one. For D, it says counterclockwise. Well, if the arrow's here, counterclockwise is this way. 90 degrees is a quarter turn. So it goes to there. And again, just going back to my black arrow to draw in would be like that. Okay. Now we have some instruction on page 54. It says to rotate point P around point 0 or origin 90 degrees clockwise. How do we do this? Well, it says draw a line segment OP, measure its length. Step 2, draw an arc clockwise to show the direction of the rotation. So from O to P, we would draw a little clockwise direction. And then we're going to actually do step 3, place a set square so that the arc points at the diagonal side of the right angle is at point O. One arm of the angle aligns with OP. So you line up this here, and then this is where your resulting dot is going to be. And so do not put it like this because it's on the wrong side. It needs to be over on this side of your line that you've drawn. It says draw a ray from point O along the side of the square. So you draw this line out and make it longer than whatever OP is. So this arrow that you're drawing here should be longer than this length. Okay? And once you've done that, on the new ray, you can measure this length right here and measure it out here and draw in your point. And you've just rotated point P around the origin, which is the dot in the middle, 90 degrees clockwise, and it has to be the same distance. So the idea here is kind of like reflections are the same distance away from the mirror line. Well, rotations have to be the same distance away from the point of rotation. And the point of rotation happens to be often labeled O. I hope you get that. Okay, question 2, page 54 says rotate point P 90 degrees around point O in the given direction. Label the image P prime. So I'm going to do B and D for you. So starting with B, here is O and P. So you can think of it as here's a line going out from O to P. And it says to go counterclockwise. So I'm going to go this direction. And I know that if I line up my triangle here, it's going to come out this way, right? And then I would draw my ray and make it longer. And then I would measure this length, which happens to be 2 over and 2 down and 2 right. So up here I'm going to go 2 and 2. And this point, and if I take out my ruler and I measure those, these will be equal lengths. So we can draw a little line on them if we want. And this is point P prime. So counterclockwise is back that way, and I can draw it in. Same thing here for counterclockwise. So again, here's my line. I start with my line segment. I line up my triangle, so you guys can do that on your page. And it's going to be something like this. I draw my ray using my triangle, right? So you guys would line up your triangle on the side like this. Anyway, and then I'd measure it out, and it would come up to about right here. P prime. Okay? Is P prime in question 2 always on a grid line intersection? It should be for question 2, so make sure you're hitting grid line intersections. Meaning a grid line intersection is where two of these lines connect. Okay, if you followed me so far, page 55, this is the hard part. It says rotate a shape around point O, or origin, rotate the shape's vertices and join the image of the vertices. So just like with reflections, we move all the points first, and then we draw in the shape. Okay? The point O is called the center of rotation, or the origin. The center of rotation can be outside, inside, or on the edge of a shape. The center of rotation is the only fixed point during a rotation. It's the only thing that does not move. Okay? So it says measure the sides and angles of the triangle, and then for B down here it says rotate the triangle 90 degrees counterclockwise around point O. Use prime to label the vertices of the image. Well, this is difficult, so I think we're going to do both of these together. So if I take B, it's going to rotate counterclockwise. It's going to go this way. So all of these points are going this way. Okay? B is 1, 2, 3, 4, 5 steps away. So after I draw in my line segment and my ray, B prime is going to be down here. So this line is going to get rotated down to here. Okay? Now I'm going to choose a different color for A. So A is over here, so I draw in my line segment. I know it's rotating this way. I get in my triangle, and I see that it's 5 to the left, 1, 2, 3, 4, 5, 6 down. So 1, 2, 3, 4, 5. 1, 2, 3. So if I put in my triangle and I draw my ray out this way with my ruler, A is going to end up right there, A prime. Okay? And I'll choose another color for C. So C is straight down. It's rotating this direction. I put in my triangle like this. I draw in my ray, and I measure out 1, 2, 3, 4, 5, 6. And it would be right here, C prime. So I'm going to erase a bunch of those lines because it just looks like a mess now, right? Oops, what's going on? One moment, please. So now that I've got my 3 points drawn in there, like you can feel free to erase parts of that if you want. But the point is I've got my 3 points drawn in. I'm going to choose another color here, and let's go with this. And again, you would be using a ruler, but basically now you just connect the points. So B prime to C prime, C prime to A prime, and A prime to B prime. Again, if I had a ruler, I would do this much more accurately. Okay? So we have now rotated this whole shape 90 degrees counterclockwise over to here. Of course, please spend your time making sure you get these parts done with your protractor and your rulers, which I can't really do because I'm zooming in and out, and I have a different size than what you have on my computer screen. Anyway, here we've got the origin on this line, so when we actually move these points, E, and again we're going counterclockwise, we're going to go that direction, and point D, we're going to go that direction. So try that on your own, pause the video, and see if you get what I get. Okay. I'm just going to hold for 5 seconds while you pause the video. So if you rotated this correctly, you should have had your triangle end up something like this. Okay, again, draw better lines than what I'm drawing. Use your ruler. Okay, let's move on to the next question. So for question 5, it says true or false. If a statement is true, explain why. If it's false, draw an example showing why it's false. A says a polygon and its image under rotation are congruent. So true or false, explain it, or give an example. If two polygons are congruent, there are always a rotation that takes one polygon onto the other. You might be able to prove that wrong with some drawings. So see if you can figure it out. Don't spend too long on it, but see if you can figure it out and then fill in the table for question 6. All right, that's it for page 54, 55, Intro to Rotations.